So hi guys, welcome to my YouTube channel. So today we solve the problem of maximum sum problems. You know about the problem? The problem is very easy, and the problem says that we have the given n number of maximum sub values with recursion. We have the n number and find the maximum sum values with three recursive breaks described below. Break into three parts, right? Each number obtained this process can be divided further recursively. At every step we can take the max of current value, right? It is if it is possible that we don't divide the number at all or choose the final answer. Okay, the problem says that given a number and we have two choice: do not break, sum is equal to n, and break n into three part, n by 2, n by 3, and n by 4, n by 2, n by 3, and n by 4, right? Then recursively maximize each part. We need what we need f of n is equal to max of n to f n by 2, right, plus f n by 3 plus f n by 4, right? Divide is floor interior divisions. Now that is a very simple approach. Like if we have n is equal to 12, then 12 by 2 is equal to 6. Then 12 by 3 is equal to 4, and 12 by 4 is equal to 3, right? So the answer is 6 plus 4 plus 3 is equal to 13. So the answer is 13, right? So this is the approaches, and this step you have to solve this problem. So if you see this, then in our mind only one thing has occurred: recursion. Why? Simple approach, recursion. Try both choice, keep and break recursively, take maximum. The formula is same we have used there. Now I just write the code, then you understand. Like return solve function of n and nothing, then just come here and int solve of int n, and in that if n is equal to 0, then return 0, otherwise return max of n to return of max of n to solve n by 2 plus solve n by 3 plus solve n by 4, right? This is, and at the end that is the solution. Now we can see there is the problem of TLE. Why? Because it will take off order of it will pass all the test cases, but yes, the time complexity is exponential, 3 to the power n. That is very slow due to repetitive calculation, right? And space is order of n. So what we can do, we can optimize, and for the optimization we can use the memoization technique, which is the DP approach, right? So in a recursion we have to one thing, that means one solution repetitively do. So for that reason it will go in the exponentials, but if we can use here the DP, then it will not go to the exponential time complexity. So I will just explain you why this will happens and how it will happens. So very simple approach, right? There is a very simple approach. I just do here to the, and that is the memoization, which means that is the top to down approach, right? So we can do here to this is the correct one. We didn't need to, we just have to write the code here from here. We have to take the unordered map int to int map, and then int solve if n is equal to 0 0, if dp here, if dp dot count, right? In that place we just have to dp, if dp count of n, then return dp dot n and nothing here, and then the simple thing is here dp of n is equal to max of this, and now try to run. Yes, and try to submit. So yes, it will submit, and in that the time complexity is order of n, space is order of n. And also the same problem I just solve in the bottom up approach, that is a tabulations form. Tabulations form is nothing just happen, and we didn't need to write the full logic, and that means a function. I just write to the create a vector int of dp of n plus 1, that is the tabulation, and again bottom to up, 4 int I is equal to 0, I greater than is equal to n, and I plus plus, right? And then dp of I is equal to I, and if I greater than is equal to 0, then dp of I is equal to max of dp of I and dp of I by 2 plus dp of I by 3 plus dp of I by 4, right? This is, and at the end return dp of n. Now so yes, and it will submitted. So yes, it will submitted. So that is the our whole full approaches and all approaches. In that the time complexity is order of n, and space is also